Lesson 2, another look at particle motion. So we have these particle motion problems, and I've never given you the actual formulas, but the formulas that I want you to remember are displacement is just the regular integral. So if there is area that is below the x-axis, it ends up being negative. So that when you add those up, it gives you that displacement. Total distance traveled is going to be the integral of the absolute value, which is not the absolute value of the integral. Okay, so please be careful. Okay, so this does not always equal the absolute value of the integral. Does not equal that, right? So please be careful of that. And then your actual position. This is the one that we focus on. I think I'm pretty sure it's in this lesson. It's either this one or the next one that we are given an initial condition. And so to find the actual position, we would take the initial position plus the displacement. And that would give us the actual position at the end of that time frame. So we're going to start by doing a little exploration here. And it says, given that S of 0 is 4, so that's the initial condition, find the displacement, total distance traveled, and position on 0, 10, where V of t is in meters per second. And this is your graph of V of t. So if we were going to look at displacement, oh gosh, sorry guys, displacement, that's going to be our integral from 0 to 10, V of t dt. And when you look at that, you say, okay, well, that's just the integral 18 minus 12. So that one's going to be 6. So the displacement is 6. Total distance, excuse me, is going to be the integral from 0 to 10 of the absolute value of V of t dt. And if we do absolute value, remember what it does? It kind of just puts this, it like folds it, and that moves up there so that they're both positive. So this is going to be 18 plus 12. That one's going to be 30. So total distance traveled is 30. And position. So if it started at 4, S of 0 is 4. It's going to be 4 plus the integral from 0 to 10, V of t dt. So that's 4 plus 6. So position is 10. Okay? So here we go. Example number 1, reviewing velocity graphs. So the graph at the right represents the velocity V of t of a particle that is moving along the x-axis on the interval from 0 to 8. V of t is measured in inches per second. For what intervals of time is the particle moving to the right? Justify your answer. So we know that when we're looking at the velocity function, that right-hand movement is going to be when the velocity function is above the x-axis, right? Because velocity is positive, that's right-hand movement. So we're going to say the particle is moving to the right between 0 and 3 and between 7 and 8. We know this because that is where V of t is greater than 0, okay? You probably technically should have put moving to the right on the time interval from 0 to 8 at times 0 to 3 and 7 to 8. So you probably should have put, that time interval from 0 to 8 in there. Okay, on what interval is the particle slowing down? Justify your answer. And remember, speeding up and slowing down, we have to analyze our velocity and our acceleration for the different time intervals. And so what we're going to do is we're going to make a little chart. We know that from 0 to 1, we have something going on. So I'm going to, that's one of our intervals. And we've got positive velocity because it's above the x-axis. And if I did the slope of the tangent line, it would be positive. So we've got positive velocity and positive acceleration. Then between 1 and 2, it's above the x-axis, so it's positive velocity. If I did the slope of the tangent line, it would be 0. Then we have from 2 to 3. We have to stop at 3 because we have the velocity is changing there at 3. So from 2 to 3, we have positive. It's above the x-axis, positive velocity. But if I took the slope of the tangent line, it would be negative. And then from 3 to 4, it's below the x-axis, so negative velocity. And if I did the slope of the tangent line, it would be negative. So that one's going to be negative, negative. Okay. The next one is from 4 to 6. And we're below the x-axis for velocity, but we are 0 for acceleration. Then we have from 6 to 7. And it is below the x-axis, so that's negative velocity. If I did the slope of the tangent line, it would be positive, so positive acceleration. And then lastly, from 7 to 8. We have positive velocity above the x-axis and positive acceleration because the slope of the tangent would be positive. So now we said slowing down would occur when our signs are different. And that's one of them. And that's one of them. That's where slowing down would occur. It does not count when you have 0 acceleration. So on what intervals is the particle slowing down, and justify your answer. And I put the particle will slow down where v of t and a of t have different signs. This is where the graph is decreasing and above the x-axis or increasing and below the x-axis. And so that is going to be for the t values, from 2 to 3 and from 6 to 7, like we had circled, okay? So when is the particle stopped and changing direction? Justify your answer. So for part C, the particle is stopped where v of t is equal to 0. It is changing directions when v of t goes from negative to positive or positive to negative. put comma at t equals 3 and t equals 7. Okay, so that's part C. Part D. On what time interval is the acceleration 0? Justify your answer. And I put the acceleration of the particle is 0, where v of t is constant, comma, at t between 1 and 2 and t between 4 and 6. Okay, example number 2. A city bus accelerates as it leaves one stop, then decelerates as it comes to another stop. The chart below measures the velocity v given in miles per hour between each stop. Find the distance in miles the bus travels between every interval using the trapezoid rule. Okay, so what I did for part A is I reminded myself what the trapezoidal rule was: 1/2 the height times base 1 plus base 2. And I started calculating between the first two intervals. Now, the only thing we need to remember is that we have minutes here. Come on. Oops. Sorry. We have minutes here, and we have miles per hour here. So we do have to make that adjustment. Come on, you crazy thing. We need to make that adjustment. And so when we do that, our height, because our height is going to be like, for this one, it's going to be 5 minus 0. We need to change it into hours. So to change our 5 minus 0 minutes into hours, we're going to divide by 60. And that puts it in hours for us. And so then we have 18 plus 0. And so when you calculate that first one, you should get 0.75. Of course, 0, 0 here is just 0, but this one's going to be 0.75. And then we're going to do the next one, okay? So then we would have 1/2, and again, your distance between 10 minus 5 is 5. So that's going to be times 5 over 60, and then this is going to be 6 plus 18. So when we put that in our calculator, we should get 1. And then our next one, 1/2 times, and then when I take 20 minus 10, I get 10. Divide it by 60 to change it into hours. 32 plus 6. And for that one, I get 19/6, which is 3.166. And then for the next one, we have 1/2 times, and 25 minus 20 is 5, so this would be 5/60. And then 4 plus 32. That one is going to give me 3/2. So this one is 1.5. And then we have 1/2 times, now I've got 30 minus 25, so that's going to be 5/60. And this is going to be 36 plus 4. And making that calculation, I get 5/3. And that's going to be 1.667. For the next one, 1/2 times 40 minus 30 is 10. So 10/60 times 12 plus 36. And that's going to give me 4. And then 1/2 times 55 minus 40 is 15 over 60. And then times 22 plus 12. That one's going to give me 17/4, 4.25. And then the very last one, 1/2 times, or 60 minus 55 is going to be 15 over 60. And times 22 plus 0. And that one gave me 11/12, which is 0.917. Okay, so there is the distance in miles, okay? So now find the total distance the bus traveled in 60 minutes. So your total distance traveled is going to be adding up all of those values. So the 0 plus 0.75 plus 1 plus 3.166 plus 1.5 plus 1.667. And guys, if this was the AP exam, I would use my exact values instead of these that we rounded. And if you use your exact values, you should get 17.25 miles. But I definitely would be using those exact values. Okay. So now some motion problems will require you to find the actual position of an object or particle at a given point in time. Remember that you will need to use initial conditions in order to find an actual position, since the definite integral only provides the change in position of an object. So example 3, an object moves in a straight line with velocity equal to the square root of 3t minus 2 meters per second, while t is in seconds. At t equals 5, the object's distance from the starting point was 12 meters in the positive direction. So that is considered an initial condition, even though it's not at t equals 0, okay? But it is a value, so at 5, it was 12 meters. Write an integral expression that will compute the object's position at t equals 10. So when we're doing this one, we're going to integrate from 5 to 10, right? Because you know that at 5, it's 12. So then if you say, okay, well, and then I need the position from 5 to 10 of square root of 3t minus 2 dt. And add that to the 12, you'll have your position at 10 seconds. And so this is your initial plus your displacement. And I went ahead and did this out, the whatever, I did all the U substitution and did it perfectly. But it had a little calculator by it, so you could have, I think it was like, I don't know, 12, I think it ended up being 12 plus 112 times the square root of 7 over 9 minus 26 times the square root of 13 over 9 or something like that. But approximately 34.509 meters. Okay. Use a graphing utility to find the actual position of the object at 10 seconds. Oh, so that's actually what I did. And I used a graphing utility. I put this problem in, and I got that answer. So that answer's right there. All right, example number 4. A particle is moving along the x-axis with velocity v of t equals negative t squared plus 7t minus 10 measured in meters per second after t seconds with an initial position s of 0 equal to negative 3. Determine the displacement of the particle on the time interval from 1 to 7. So if you only want displacement, you are just integrating from 1 to 7. So this would be the integral from 1 to 7. You're integrating velocity. Negative t squared plus 7t minus 10 dt. So if we do that, we've got negative 1/3 t cubed plus 7/2 t squared minus 10t from 1 to 7. Negative 1/3 times 7 cubed plus 7/2 times 7 squared minus 10 times 7. And then minus, now if I put a 1 in, I'm going to get negative 1/3. If I put a 1 in there, the next one I get positive 7/2. And if I put a 1 into the next one, I get negative 10. So this is going to give me negative 300, oops, shoot. Try that again. Negative 343 thirds plus 343 halves minus 70 plus 1/3 minus 7/2 plus 10, negative 6 feet is my displacement. Or actually, I put feet. It's supposed to be meters. Sorry, I don't know why I put feet. Negative 6 meters, because that particle moving along and meters per second. So negative 6 meters. That is the displacement. So what is the total distance traveled by the particle on the time interval from 1 to 7? Well, we know that it started at 0. It was negative 3. So if we want to find total distance traveled, we are going to have to break up this integral. And it's really good to know what your where your zeros are for your velocity function. So this negative t squared plus 7t minus 10, if I factored a negative out and then tried to factor this, so I've got a negative 5 and a negative 2. So my t equals 5 and my t equals 2. I know it's a downward facing parabola. And so here's 2, here's 5. So it goes something like that. So I know that it's negative from 1 to 2, right? And so I'm going to, when I integrate, I'm going to get a negative value if I integrated from 1 to 2. And then if I integrated from 2 to 5, actually I'm going to get negative from 0 to 2. And then I'm going to get positive between 2 and 5. And then I'm going to get negative anytime after 5. So I'm going to say, if they want total distance traveled by the particle on 1 to 7, I'm going to say that the integral from 1 to 7 of the absolute value of v of t dt is equivalent to, I'm going to put a negative in front of the integral from 1 to 2 because my answer to my integral is going to be negative, and if I multiply it by a negative, I'm going to get that positive value that I want. And then I'm going to say plus from 2 to 5, that integral, because it's positive, but then I'm going to say minus from 5 to 7 because I know that the answer to that integral will be negative. So if I put a negative in front of it, it'll turn it into a positive. And that's how you split those up to calculate your absolute value without a calculator. And I did all this without a calculator, right? And they'll set these problems up so that they can be solved so that you can find those zeros, okay? So that you can do it without a calculator. So now we've got, I went through this whole thing, negative 1/3. You might want to just go out of here and do the same thing. And see if you can get this. This from 1 to 2. And then positive, you've got your same integral. From 2 to 5. And then minus, you've got your same integral. From 5 to 7. And what I ended up getting should have been minus a negative 11/6 plus 9/2 minus a negative 26/3. So that's 11/6 plus 9/2 plus 26/3. And so if I change them all to 6, 11 plus 27 plus 57 gives me 96, which is 15. And I put feet again, meters. Okay? So that is the total distance traveled. Okay? He ended up being -6 away from wherever, but and look, we didn't even use that initial position because it didn't ask us anything on those two about the initial position. But, sometimes it is going to ask us, but that particular problem didn't even ask us. All right, example number 5. Suppose you are driving in traffic behind a large bus at 66 feet per second. This is 45 miles per hour. When you finally get a chance to pass, you step on the accelerator, giving the car an acceleration of a of t equals 4 over the square root of t, where a is measured in feet per second, and t is measured in seconds. How fast are you going 16 seconds later when you have passed the bus? So basically, we're thinking that you are driving in traffic behind a large bus at 66 feet per second. That's like your velocity at time 0. Okay, we're just gonna call that velocity at time 0. Okay. So what they want to know is how fast you're going at 16 seconds later. So they want to know what is your velocity at 16, right? So let's think about what our velocity is based on because all they gave us was acceleration. So we could find velocity by integrating our acceleration function. So integral of 4t to the -1/2 dt is going to be 8t to the +1/2 plus c. And we say that, if this is our v of t, and if we knew that our v of 0 is 66 when t is 0, that means by putting in 66 here and 0 for t, I get c equals 66. So my actual velocity equation is going to be 8 times the square root of t plus 66. And so if I wanted to find my velocity, I'm going to just... And I know that I want to find my velocity at 16. That's going to be 8 times the square root of 16 plus 66. So 8 times 4 is 32 plus 66. So that's going to be 98. And that's going to be feet per second. Okay, so the velocity... How fast are you going 16 seconds later when you have passed the bus? 98 feet per second. How far did you travel during that time? So that means we're looking for total distance traveled. And that's going to be our integral from 0 to 16, absolute value of v of t dt. And so since I know that this square root function plus 66, it's always above the x-axis, right? So that's going to just be the integral from 0 to 16 of 8t to the 1/2 plus 66 dt. So that's going to be 8 over 1, and then when I add 2 halves to the 1/2, I get 3 halves, but then when I divide by 3 halves, I'm multiplying by 2/3. And so I've got 16/3, and then I've got the square root of 16 to the 3rd power plus 66 times 16. And so this gives me 1,024 thirds plus 1,056. So 4,192 over 3, which is approximately 1,397.333 feet. Okay, total distance traveled is this. What is your average velocity for the 16-second interval? Remember, average is 1 over 16 minus 0 times the integral from 0 to 16, v of t dt. And so I'm really just looking at 1/16 times that 1,397.333. And so it's going to be about 87.333 feet per second. It's our average velocity. All right, so now you drop your calculus book from a window 48 feet above the ground. How long will it take for your book to reach the ground? So initially, if you're just, holding it and then you let it drop, it has an initial velocity of 0. The initial acceleration, or the acceleration anyway, is negative 32 feet per second. Feet per second squared, excuse me. And so its initial height, which is your s of 0, is 48 feet because it's 48 feet above the ground. So your velocity function is going to be found by integrating your acceleration. So this is going to be negative 32t plus c, right? And since we knew that our initial was 0 at 0, our c is 0. So actually our velocity function is just negative 32t. And so then if we wanted to find our position function, we're going to integrate our velocity function. And so this is going to be negative 32 over 2 t squared plus c. And since its position was 48 at 0, our c is 48. When I put 0 in there, I just get c. And so therefore your position function is going to be negative 16t squared plus minus 48. No, plus 48. What am I doing? I was thinking moving it over. Plus 48. All right. So now, how long will it take the book to hit the ground? Okay, well, we're going to take our position and set it equal to 0. And so I would put plus or minus, but we won't have negative time. So square root of 3, so it's going to take t equals the square root of 3 seconds for the book to hit the ground. And then what is the velocity of the book at the instant it reaches the ground? So if my velocity function is negative 32t, my velocity at the square root of 3 is negative 32 times the square root of 3. And if I put that in my calculator, negative 55.426 feet per second at impact. And then we have example number 7. A particle moves along the x-axis so that its velocity at time t, for t between 0 and 15, is given by a differentiable function v, whose graph is shown below. At time t equals 0, the particle is at x equals 4. So that's your initial position. The velocity is 0 at t equals 3, 9, and 13. The graph has horizontal tangents at t equals 6 and 11. The areas of the regions bounded by the t-axis and the graph of v on the intervals 0, 3, 3, 9, 9, 13, and 3, 15 are 6, 9, 3, and 2 respectively. Okay? So for t between 0 and 15, find the time and position of the particle when the particle is farthest to the right. Well, it starts at 4, right? So if I wanted to know what it was at after, this initial positive 6 here, I would say that the position at 3 is going to be 4 plus the integral from 0 to 3 of v of t dt. And so this is going to be 4 plus 6. That's going to be 10. And then I know it's going to go negative. So, if it starts at, we're talking about how far away it is to the right. So, here's 0 on the number line, right? We're just going to imagine it's on the number line. So it starts at 4 and it moves to the right to 10. Okay, so it is, it's pretty far to the right. Then it goes 9 this way. Okay, so now it's at 1. Then it goes 3 more. And now it's back at 4 again. Then it goes 2 back. So the furthest it is away, you could think, oh, well, I compared it to x of 13, which was 4 plus the integral from 0 to 13 v of t dt. And so that was 4 plus 6 minus 9 plus 3. Because I knew that, I was thinking, well, those last ones, it's going to move further to the left. So if I just look here, that takes into account my 6 and my 3. Yeah, it lost 9 before that, but let's just at least take into account all of that. And so you've got 10 minus 9 plus 3. So 1 plus 3 is 4. So I know that then the furthest it was from the right was when it was at t equals 3. So I put, when it says justify, I said v of t is greater than 0 on the interval from 0 to 3 and the interval from 9 to 13. And I put the particle, so I wanted to see what it was doing after it did all that positive and after it did all that positive. So I put the particle is farthest to the right at t equals 3. So farthest to the right. It's hard to write with this thing sometimes. For how many values of t between 0 and 15 is the particle at x equals 4? And explain your reasoning. And so I put the particle is continuous. On x of 0 equals 4 to x of 3 equals 10. Also, x of 3 equals 10 to x of 9 equals 1. X of 9 equals 1 to x of 13 equals 4. And x of 13 equals, x of 13 equals 4 to x of 15 equals 2. So by the intermediate value theorem, there are 3 values for t where the particle is x of t equals 4. Okay? On what interval is the speed of the particle increasing? Give a reason. So the speed of the particle is increasing. On the intervals, t between 9 and 11, since v of t is greater than 0 on that 9, 11 interval, and velocity is increasing. Oh, because the acceleration is positive. Also, I'm going to move that down here, the interval from 3 to 6 and 13 to 15, since v of t is less than 0 and velocity is decreasing on these intervals. Okay, so for speed to be increasing, it's speeding up. And speeding up, you're looking for when the velocity and acceleration have the same sign. Okay? All right, so during what time intervals, if any, is the acceleration of the particle positive? Justify your answer. So we're going to say the acceleration of the particle is positive on the interval between 6 and 11, since velocity is increasing on this interval. So that's how, when they haven't given you, when they've given you the velocity as a graph, you're going to talk about increasing velocity